problem number 4. That is their matrix that rotates theta degrees. So now they want us to compute r sub pi over 3. They want us to compute the matrix. Well, it's just going to be cosine of pi over 3, the sine of pi over 3, the negative the sine of pi over 3, and the cosine of pi over 3. But this is a very special matrix. Pi over 3 and pi over 6. This is 1, 2, and the square root of 3. Well, the cosine of pi over 3 is adjacent over hypotenuse. It's 1/2. So that gives me those two numbers. And the sine is the opposite over the hypotenuse. That's the square root of 3 over 2. And that's also what I circled, the square root of 3 over 2. But there is a minus in front. So that is the answer to part A. Now they want us to compute the inverse of that. Okay? They want us to compute the inverse of that. So, in case you want this here, let's just move it over. Okay, this is 1, and that's the square root of 3. Okay, so now r inverse of pi over 3. So yes? You feeling better? So if you rotate 30 pi over 3 radians and you want to undo that, that means you want to rotate negative pi over 3. And that matrix is going to be the cosine of negative pi over 3, negative the sine of negative pi over 3, the sine of negative pi over 3, and the cosine of negative pi over 3. Now, the cosine has the following property. The cosine of any angle is just the cosine of the angle. That means the cosine of negative pi over 3 is just the cosine of pi over 3. Same thing down here. Now, the sine of a negative angle, that also has the sine of the angle without the negative. But then negative comes in front. This negative comes in front. So it's negative the sine of pi over 3. The negative comes in front. Coincidentally, there's another negative in front. So we get that. But the cosine of pi over 3 is 1/2. We calculated that a while ago. And the sine of pi over 3 is square root of 3 over 2. So this is the square root of 3 over 2, and this is negative the square root of 2. So the matrix that does that computation is this one right here. Okay, this first matrix is equal to this matrix. That's why I bothered to put the equal sign, and that matrix in turn equals this matrix. That's why I put the equal sign, and that's the final answer. Okay, now I just have a feeling that what we just did was part B. Yes, that's part B. Okay, so now, first let us decide what matrix corresponds to S. Also for part A, so let me just say A continued. Same mistake I made last time. Not only did they ask us to compute R sub pi over 3 to find that matrix, they also want us to find the matrix that reflects about the x-axis. So we have the point xy, and here's the x-axis. Maybe that point is right there. It could have been over here. But when we reflect across the x-axis, the x value doesn't change, but the y value does change. Instead of the y value being up there, it's now down here. It's x negative y. So we want to get x negative y. Well, if I put 1, 0, that gives me the x, and if I put 0, negative 1, okay, so S is equal to 1, 0, 0, negative 1. I did not know the answer to this, nor did I know it last time, but it's easily derivable. That is what S equals. Now, they want us, so that's the end of part A. I found R pi over 3, and now I found S. Now they're asking us to find the following. S R pi over 3, they want us to show that these two are inverse pi over 3 times S, that these are equal. So I'm going to compute this, I'm going to compute that, and I'm going to say, hey, everyone, look, they're the same answer. Okay, now S is this. Let's write down what we're doing first. S R pi over 3. Well, this here is S, and now I need to multiply it by that matrix. Well, let us go up and find that matrix. R pi over 3. Okay, R pi over 3 is this matrix right here. Let's see if we can just copy this. One thing I want to get rid of is that equality sign. Okay, so we multiply these two matrices and we get what we get. First row by first column is just a half. First row by second column is negative radical 3 over 2. Second row times first column is negative radical 3 over 2. Second row by second column is negative a half. Okay, so I did this one. Now I need to do this. What is R inverse pi over 3 times S? Well, I'll put R inverse in a moment, and here is S. What's R inverse of pi over 3? our inverse of pi over 3 is this matrix right here. Let's go and grab it. Good, I don't want that. Beautiful. Don't want that either. Don't want that. Aha. Okay. This is just 1/2. Let us multiply the first row by the first column. I get 1/2. First row by the second column. I get square root of 3 over 2. And the first row by the first column is negative square root of 3 over 2. And then the first row by the second column is negative 1/2. And we definitely have a problem because, in fact, the two answers are not equal. So let us see which one I copied down wrong. Either this is not our inverse, or this above is not r pi over 3. So I'm pretty sure that that's r pi over 3. Ooh, boy. Okay, so the only calculation I made wrong was at the end. When I do the first row by the first column, I should get a negative right here. I should get a negative. Now, these two are equal. Now remember, this one here equaled this. And this one here equals this, which equals that. Therefore, those two are in fact equal. Okay. Now, I take it that this was letter C. Now, for letter D, they want us to show that S rotation of 2 pi over n is equal to R inverse 2 pi over n times S. They want us to show this. Okay. So you have S, which is 1, 0, 0, negative 1, times the cosine of 2 pi over n, the negative the sine of 2 pi over n, the sine of the angle, which is 2 pi over n, and the cosine of 2 pi over n. Well, the first row times the first column is just the cosine of 2 pi over n. The first row times the second column is negative the sine of 2 pi over n. The second row by the first column is negative the sine of 2 pi over n, and the second row by the second column is negative the cosine of 2 pi over n. So that's the answer to, SR 2 pi over n equals. We just did this. Now let us try this one, S inverse of 2 pi over n times S. Well, if you rotate 2 pi over n in one direction, to undo it, you rotate in the same amount in the other direction. This is just regular R rotating 2 pi over n times S. This is the cosine of negative 2 pi over n, or negative the sine. We need a little bit more space. Negative the sine of negative 2 pi over n, the sine of negative 2 pi over n, and then the cosine of negative 2 cosine over n times S, which is 1, 0, 0, negative 1. But before I do that, I'll use that rule that we had before. The cosine of the negative angle is just the cosine of the angle. Same thing down there. You could ignore the negative sign. This negative sign comes in front, which is going to make it positive sine of 2 pi over n. This negative sign's going to come in front, which makes it negative sine 2 pi over n. And I multiply this by S. 1, 0, 0, negative 1. First row by first column is cosine 2 pi over n. First row by second column is negative the sine of 2 pi over n. The second row by the first column is negative sine of 2 pi over n, and the second row by the second column is negative cosine of 2 pi over n. And if you look, if we can look, these two are equal. They're exactly the same. That is, this composition, it equals this, and this composition also equaled this. So, in fact, these two are equal, and that's what we were asked to show. That completes number 4.